Hello, I'm Dr. Hai Macedo and I'm a senior lecturer at the James Watt School of Engineering at the University of Glasgow. And let me start this by asking you a question. What do you think is the most important invention in history? It's a very difficult question, right? So many good answers. For example, you could say the wheel. Before that, humans couldn't go very far or couldn't transport a lot of stuff on land. Then there was penicillin, which changed the way that medicine works and fights bacterial infections. But what if I told you that the biggest invention in modern era is perhaps a little thing called the transistor? I understand you might be thinking, really, the transistor? Or even thinking, what is a transistor? Well, this is exactly what you learn in this video. Modern transistors come in many different shapes and sizes. For example, here I have two, the MOSFET and the bipolar transistor. Transistors are small electronic components which have two main features. They can either act as a switch in electronic circuits, or they can work as amplifiers. The interesting thing about them is that they are not mechanical. You might be thinking of light switches where you have to go and press a button somewhere. That's not how transistors work. They are actually automated. They have 3 pins, which are called the emitter, the collector, and the base. If you put this into a circuit connecting the emitter and the collector, nothing will happen. They'll just block the whole circuit. But if you then apply some voltage to the base pin, your circuit will now be on because you essentially turned on the transistor if your voltage is significant enough. And that is exactly what Adam's trying to do here in the lab.
In this circuit, I'm using a transistor as an electronic switch. So the way this circuit works is you vary the voltage across the base pin here. If the voltage is high enough, it allows current and voltage to flow from the collector to the emitter, which would turn the LED on. At the moment, the voltage across the base pin is not high enough to turn it on, but if I increase the voltage and current, it will turn on. You can vary the voltage across the base pin so that the LED is slightly on, it's a bit dimmer, a bit brighter, or completely off.
Transistors have a turn-on voltage, and we can check this by measuring the voltage between the base and the emitter. And as we turn up the voltage at the base, we can see there's a certain point where the transistor turns on and the LED turns on. Current flows from the collector to the emitter, and if the transistor was the other way around, then the circuit wouldn't work and the LED wouldn't turn on.
Now, you might be asking, how did we get here in these modern electronic circuits as you've just seen? Well, early electronic circuits worked much like light switches, where everything was mechanical and you had to turn it all on and off manually. Then, in the early 1900s, there was something called a vacuum tube triode, which was an electronic device which looked very much like a light bulb, where electricity would go in, heat up a filament inside, and that motion of electrons inside of vacuum would control electronic circuits. And then in 1947 at Bell Labs, there came the transistor. The first transistor that looked something like this was created out of a plastic stand, a chunk of germanium, which is semiconductor material, a plastic triangle, and this squiggly wire here on top is a spring which presses the apex of the triangle into the germanium. Now on either side of the triangle there is gold foil. So if you give an electronic signal to one side of the triangle, that signal was amplified on the other side, up to 100 times. Now, this was big news, and you might be thinking of amplification, and that is because this was one of the first things that the transistor was used for, to make hearing aids, where you would take the low sounds from the environment, and then you would amplify that into the user's ears. So you may be asking, why was this so revolutionary? Well, if you think about its predecessor, which was the vacuum tube triode, this was working really well. By the 1920s, vacuum tube triodes had already enabled sounds in movies and even long-distance phone calls. The problem with vacuum tube triodes was that they were big and they were difficult to use in electronic circuits. The glass casing was quite fragile and, as you can imagine, would need quite a lot of replacement. So then it comes the transistor. At its first iterations, it was already much smaller than the vacuum tube triode. Then it became hundreds of times smaller. And that is because it was created out of solid state. By that I mean The electricity was flowing through the solid state of matter, the material itself, which, if you think of the first transistor, was the germanium. There was no glass tubes, there was no electricity flowing through vacuum. It was all done inside the material. By default, this was also less fragile because there was no glass to break or anything like that. It didn't need as much power to heat up anything. In fact, it didn't need any power at all in some instances. So this was a really big revolution because you could now scale up electronic circuits a lot more than you could ever with vacuum tube triodes. Because these devices are so efficient and so versatile, they are now embedded in pretty much every piece of electronic that we have. They are in fact what enable every single computational event taking place ever. If you think about how computers work, to send a message, to watch a video, your computer needs to create a sequence of zeros and ones, which inside is just a sequence of electric signals either on or off. And that is all done using transistors. However, you can't use just one. In order to do that, you need to use many of them. In fact, thousands, millions. By putting transistors together, that is what we would call an integrated circuit. But there is a problem. If the first transistor was something about this size, how can we have so many of them inside our computers, inside our mobile phones? That is how transistors needed to become much, much smaller than what they used to be. But from the 40s, when this was invented, to the 80s, transistor sizes had reduced significantly. It had gone from millimeter sizes into micrometer sizes. Nowadays, transistor sizes are in the nanometer range. For example, companies like Intel are mass-producing transistors that are only 14 nanometers across. That is just 14 times wider than DNA molecules. They are made of silicon, which makes them only about 70 silicon atoms wide. So these nanometer-sized transistors are used to build something called a microprocessor, which is where billions of transistors would be put together into a single chip to perform a series of operations. That is in fact what is inside every computer, laptop, mobile phone in the world. This is actually what enables them to be so small compared to what computers used to be. In fact, there is probably more transistors inside your mobile phone than there are people in the world. Just for perspective, if you were to build a mobile phone out of the transistor's predecessor, which were the vacuum tube triodes, your phones would probably be the size of the Empire State Building at least. And you would probably need someone to be there replacing the vacuum tubes every time that you tried to make a phone call, just because of how unreliable they were compared to the transistor. Now, we've seen earlier on how we can make some very simple circuits with a transistor, which was just to light up an LED, but we can also make some things that are more sophisticated than that. Here at the University of Glasgow, through your electronics degree, that is exactly what you'll be doing, and Morven can tell you a lot more about that.
When you reach third year of electronic engineering, one of the projects that you could be tasked with is creating a line-following robot, which is also capable of detecting objects in its path. For the project, you'll be given an empty chassis of a rover and also a microcontroller. The microcontroller contains a single chip, which has tens of millions of transistors on it, which are just nanometers apart. They send messages really, really quickly to each other to control the operation of the rover.
Transistors are by far the most common human artifact on the planet. Deeply embedded in everything electronic, transistors permeate modern life almost as thoroughly as molecules permeate matter. Portable equipment based on this remarkable device can be found almost everywhere in the world, from the big metropolises to small hamlets. By enabling the information age, the transistor has made the world a far more intimately connected place than ever before. So it's no exaggeration to say that this tiny invention brought about a huge technological revolution that changed the world into this ever more interconnected global society that we live in today. And now that you learned all about the transistor, I look forward to seeing you in Glasgow in class. Thanks for watching.